Hello, this is day one of chapter 12. This is a new chapter on sequences and series. So without further ado, here are some definitions. A sequence is, simply put, just, let's call it an ordered, that's an E, list of numbers. And each number in this list is its own term. So it's a number in a sequence. There may be a time in which there's a variable there, here and there, but the spot in a sequence, the quantity that resides in a spot in a sequence, like the fifth term of a sequence, is the number that's in there. An arithmetic sequence is a sequence in which each next number can be found using addition or subtraction. So like that's kind of the rule in which the sequence generates the next sequential number. So an arithmetic sequence, arithmetic refers to addition or subtraction, is the rule of the sequence. And it has to be consistent. It can't just like start changing its rule from one number to the next. It has to be a consistent pattern. And with that, the common difference is how much each number changes from one term to the next. And again, it has to be consistent. That's why it's called common difference. It's always the same amount that it changes. And so here's a formula that we could use as an explicit formula. You should copy this down, have it handy. This formula allows us to find any term in a sequence if we know enough information. And so we have some notation here, and it can be sometimes confusing, but these little subscripts here, 1 and n, they just tell us which term we're talking about. So a sub 1 would be the first term. That would be the first, in a sequence, and you can write it however you'd like, usually with commas, but if we want to think about it as spots in the memory of a computer, that's sometimes how it could be thought of as your first spot, second spot, third spot, fourth, fifth, sixth, and seventh, or whatever. This would be the a sub 1 spot, or this would be the first spot, and your number a sub 1 is in there, the number that is in the first spot. And it could go for some time, and since we don't know what we're talking about, maybe it's the end of the list, or if we're talking about the seventh term, then it'd be a sub 7 in this spot. But a sub n, if we don't know, be the last term or the nth term. So we'll use that formula. We could probably forego the formula on a couple of these. Find the next 4 terms in the arithmetic sequence. Here's an example. And we're typically very good at recognizing patterns. So we would just see that it goes -12, -1, 10, and so on. So when -12 changes into 1, that's sort of like you are adding positive 11. It's like plus 11, and we see that it's consistent because we add a positive 11 again, we get to 10, and we would just continue on that pattern to find the next 4 terms. So the next term after 10 would be plus 11. That would put us at 21. Plus 11 would be 32, plus 11, 43, plus 11, 54. And that would be the next 4 terms. Where the formula comes into play is you're going to have to start putting together what all those variables mean. So let's look back. We talked about a sub n and a sub 1. D is the common difference. That's like in our first example, that would be plus 11. That's like how much it's changing each time. And n is the term position in which you're looking for. So if we want the 41st term, suddenly we know that n is the position we're looking for. The 41st term, like the number that goes in the 41st position, is a sub 41. We know some other things about this. We have this sequence that starts at 11. Starts indicates that a sub 1 is equal to 11. And then without too much thinking, we could look and see that 11 goes down to 4, goes down to -3, goes down to -10. That's a common difference of -7. So the only thing we don't know is a sub 41. That's the number that is the 41st term in the sequence. It's the number that's the 41st in the 41st position. And we can find that a sub 41, again, this is a sub n equals a sub 1 plus d times n minus 1, the formula. And you'll see how we're plugging everything in. A sub 1 we know is 11, plus a d is a -7, so this is now a -7, times n minus 1, n was 41, and then we have the -1 there. Okay, so we could do order of operations just to simplify this side and get what a sub 41 is. Parentheses first, this would be 40. -7 times 40 would be a -280. So this would be 11 plus a -280. And then if you added those together, we'd get a -269. So this should make some kind of sense. We're going subtract 7 each time from each number. When we do that to the 41st position, we end up with -269 in that spot. We can take it a step farther, the next example, and kind of figure out, like work backwards to figure out what the first term might be. So we're going to find the first term. That means we're looking for a sub 1. We know that a sub 44 is 229 and d is 8. This also means we know that n is 44, because if we're using a sub 44, n would have to be 44. So same formula as right here. This would be 229, because that is a sub 44, a sub n, equals a sub 1, we don't know it, plus 8, it's positive, d is positive 8, times n minus 1, 44 minus 1. All right, maybe take a calculator to calculate some of this if you need to. 44 minus 1 is 43. 8 times 43, 344. And then our last steps are just to solve for a sub 1. So just being added, we'd subtract 344. And so that's 101.5 equals A1. So -115 is what our starting term would be if our common difference was 8 and our 44th term was 229. Similarly, we have a couple other problems in which we may solve for something different. We see we're going to find d, so that means we don't know d. We know a sub n and a sub 1, which means we also know n. It's 68. So this would be 1,134 equals -5 is a sub 1 plus d times 68 minus 1. All right, and then we had a d there. And then 68 minus 1 is 67. Our first act would be to add 5 to each side. This is 1139 equals 67 times d, or d times 67, but either way we're dividing. We're used to seeing the number up front of d, that's why. 1139 divided by 67, 1139 divided by 67. 17 is d. That means our common difference, the amount that we're going up each time, is 17. If we started at -5 and we found the 68th term using 17 as our common difference, we'd end up with 1134. And finally, there's a couple more examples here. We want to find n. That's the only thing we haven't solved for yet, really. If a sub n is 38, and a sub 1 is negative 16, and d is 4.5. So now we don't know what n is. We could fill in the rest. 38 equals a sub 1, negative 16, plus 4.5, and then n minus 1. So just to solve this sufficiently as possible, add 16. We get 54 equals 4.5 times n minus 1. Previously, or in earlier levels of math, we would say, well, that's something we can distribute to simplify it. Sure, it's true, but n is stuck in parentheses. If I got the parentheses by themselves, it would have the same ending. I'm going to divide by 4.5. And this should be 12, but I'll check it. So then we are at 12 is n minus 1. The last step would be to add 1 to get n by itself. So it's actually the 13th position, 13th term in our sequence. Then there's one more type of problem, which kind of seems hard to understand. It says, write an arithmetic sequence that has 6 arithmetic means between 12 and 23. So we don't really know what the first term is or what the last term is, but we know that at some point it goes 12, and then there's 6 unknown terms. 1, 2, 3, 4, 5, 6. And we end up at 23. So we kind of don't care, since an arithmetic sequence has to follow the same rules throughout. We don't care if it's the first or last term or the middle of the sequence. I can just pretend for a moment that this is a sub 1. If a sub 1 is 12, now we know something. We could also figure out what 23 is. If there's 6 in between these two, this would be the first, second, third, fourth, fifth, sixth, seventh, eighth. This would be a sub 8. And so we now know a sub 1, a sub 8, which means we also know what n is, if n is 8. The thing we don't know, so I worked backwards in my logic here. What we could have started with, like, what are we even doing? I just started putting down everything I know. But if we're going to figure out what these blank terms are, the thing we need to know is what d is. And coincidentally, or not, when I wrote down everything I knew, the thing I'm missing is what d is, the common difference. So that's what we're solving for. This would be, we're saying n is 8, so a sub 8 is 23, equals a sub 1, negative 12, plus d, and then n minus 1. So we could go about solving this guy. Add 12. That gives us 35 equals 8 minus 1 is 7. 7d. Divide 7, we get 5. So if d is 5, that's all we have to do. We have to use d to just figure out each next term, and we know where we're starting. Negative 12 plus 5 is a negative 7. Plus 5 again is a negative 2. Plus 5 again is a 3. Plus 5 is an 8. Plus 5 is 13. Plus 5 is 18. And we got to hope we end right. Plus 5 is 23. We did. So then these would be this would be the arithmetic sequence that has 6 arithmetic means between negative 12 and 23. And notice these are all evenly spaced. We made it. We wrote the arithmetic sequence. All right, again, here's the formula one last time. And we'll be using that a lot. Probably memorize it. If you don't yet, then please write it down. All right, thanks. Good luck.